Hello! In this video, we will review some of the basic principles of logical implication. Now, this material is very important as it serves as a foundation for most of the questions that we'll be asking throughout this course. And so, in math in high school and even in some introductory college courses, don't really teach math. What they teach is computation. And so that's a very important distinction for what we're about to be going over today. So computation versus math. And so what do I mean by that? In high school, we often learn how to solve problems like this. 2x plus 3y plus 5 equals 0. 4x plus 5y plus 9 equals 0. Something like this, right? So we'll go through a process and we'll ultimately find out that both x and y must be minus 1. Right? We're computing the values of x and y. So our result gives us an output of numbers, just like this. Similarly, in late high school or even early college, you might learn the following thing: how to calculate the integral from 4 to 16 of a function x squared dx. You'll learn that this 2 up here should be increased to a 3. We divide by 1 3, and so then that equals what? 16 cubed over 3 minus 4 cubed over 3. Right? And so this is going to be the numerical answer. So a lot of computation is finding a number solution. We are asked to compute a value. In contrast, in pure mathematics, the focus is much less on how to compute something. Often falls within the field of applied mathematics. But rather, we care much more about the properties of objects. So properties of objects. And how these properties relate objects together. So how does one object A relate to object B? And so by zooming out of details of exact computation, finding these numbers, instead focusing on how objects like numbers, so complex numbers, groups, vector spaces, and other objects behave, we can gain insight that is applicable in many more situations. And so this is a very powerful tool to abstract away these properties of objects. And so to understand how objects behave, we're often concerned with statements of implication. And so for instance, statements such as, if A is true, then we know something about B, where A and B is a statement. And so such statements are called if statements appropriately. And they work in the following way, where if A, then B can be interpreted as if A is true, then B must also be true. So for example, if we let A be the statement that you're watching, do a little I, you're watching this video, and B is a statement that you're human, then this if statement can be interpreted as, if you are watching this video, then you are human. And that makes a lot of sense, hopefully, that usually humans are the ones watching this video. So the symbol that we use to denote this direction of implication, right? So if A, then B, is the following. A implies B. So what I mean by this, where here this symbol means implies, is that if you are watching this video, then you must be human. So watching this video implies the fact that you are a human being. Now, we can switch up the order of this if, which you'll very often find, in the following way. So let's say that we have A, or let's actually do it with B. So we have B if A. So here this is saying B is true if A is true. Where this can be interpreted as you are human, right? So you're human if you are watching this video right now. The direction of implication for this statement is now backwards. What I mean by that is that we still have A implies B. So when we have if A then B, the direction is forwards, whereas if we have B if A, then we have the direction is backwards. I would strongly recommend that you sort of read through those statements a few times to make sure you understand why the direction switches if we put the if statement over here. So in all of these statements, remember too that you do not need to be watching a video to be human, right? So that's the power of this if statement over here. So there are other conditions that can allow you to be human. So for example, you can be doing math. So if we had another statement C, which was you were doing math, so 1 plus 2, right? Then that can also imply that you're human. Now the fact that there are many things that might imply B over here leads us to our next topic, which is an only if statement, which restricts what things can imply something else. And so here, for an only if statement, we have A only if B. And this can be interpreted as you are watching the video right now only if you are human. Or in other words, given that you are watching the video, then you must be human. You can't be anything else. Note the distinction here between the directions, where even though we had the only if in the middle, the direction of implication is still in this way. So for example, knowing that you're watching the video right now directly implies that you are human, or over here. Whereas if we had A if B, the direction would be the other way around. So, very often in math, to show that two statements are logically equivalent, we often use A if and only if B, which is the same thing as A if and only if B. Or A implies B and B implies A. This gives us logical equivalence. So this can be interpreted as you are watching the video right now implies that you are human, which makes sense, and you being human implies that you're watching the video right now. Which direction is the if statement? The if statement here has the B implies A, which is that you are human implies you're watching the video right now, which is probably an unrealistic thing because there are many humans not watching this video right now. And so the if is the backwards implication in this statement, and the only if, as we mentioned before, is the forwards implication. So it's very important to understand which direction is the if statement and which direction is the only if statement when we're comparing two objects or statements like A and B. And so now this brings us to the end of our video on logical implications. And so I strongly recommend that you check out the exercises on the very next lesson to make sure that you understand the above material, as we're going to be using these statements frequently in all of our future videos. Until then.